Okay, guys. So as I was saying that, I was using the example of clubs. When you are in school, you may have a person may wanting to be in more than one club, so they will be in the overlapping region in terms of the Venn diagram. All right, so in this case, we would, even though we are focusing on the union, we still have to draw the Venn diagram to account for any intersection that may occur. All right, so note that 7 occur once, even though it occurs is common in both sets. All right, so in the union, we only write it once. All right, moving ahead. Now, intersection of 3 sets are not really, say, a part of the CSEC syllabus anymore, but in order to kind of reinforce your understanding of what it means by intersection, I will also be looking at intersection of 3 sets. All right. So looking at, it is quite usual to have intersection between 3 or more sets. Now, intersection of 3 sets, A, B, and C, is denoted by the shaded region in the purple section. So intersection of all 3 sets, that purple region would be the region that you would have a member or members common to all 3 sets. So if they are not in that middle purple region, then they are not in all 3 sets. So that's where you have the intersection for 3 sets. All right, so that region is referred to as A intersect B intersect C. Now, and as I say, just to recall, I am doing 3 overlapping sets for the purpose of reinforcement of the concept of intersection of sets. So it is not being taught for you to recognize it as a material to study. You're not really going to study for your exam, because for your exam, the set is now limited just to the multiple choice. You seldom see any sets in terms of paper 2. I'm not saying that it is impossible to see questions in paper 2 with sets, but you will find it more so on the multiple choice. And so most often when you see them, they are limited to 2 overlapping sets. All right, they don't generally have any 3 overlapping sets. So, but for the purpose of reinforcement, we are looking at 3 overlapping sets. So if you have these 3 sets, A equal to the set of elements 1, 2, 3, 4, 5, and B equal to the set of elements 2, 3, 5, 6. C equal to 2, 5, 6, 7. Now, in terms of what members are common to all 3 sets, how can we identify these now? So from the listing, what are we looking for?
Sir, the numbers that occur the most.
For the intersection, we want to find numbers that occur in all. Right. So what are the numbers, are the elements that occurs in all 3 sets?
2 and
3.
So 2
and 5.
So those are common in all 3 sets. And so if we are to draw a Venn diagram representing this, it means that we would have to draw all 3 sets overlapping, just as how we had seen it, the slide before this one, right? And so, of course, let us see if we could construct a Venn diagram for this. I'm going to ask you to assist me in putting in the elements, right? So first, let me start off with our rectangle. And we're going to look at, all right, so I'll probably draw these circles using the same colors. Oops. All right, so not drawn to scale. And now we want to label our sets. So if we call this, let us use a different color for our labeling. So this is a set A. This is a set B. And this is a set C. Now, can you now assist me in putting in these members in the various region on the diagram? So what are we going to put in first? If you're labeling a Venn diagram, when you're labeling a Venn diagram, what you want to do is start from the intersection of all the three sets. So you put in your middle intersection first and you work your way out from that center area. So what are we putting in first? So this region is the region where we have intersection of all three sets. So the members that are common to all three would go in here. So we'd have which numbers going in here?
2 and 5.
2 and 5, right? All right. So having done that now, we have some other members. And so what we need to do is to look based on the sets. So look at A and B. And so because A and B only would be right here. So you want to look at the set A and B and see if there's any other member common to A and B that
3, sir.
which one?
3.
3.
Right. So we would now circle 3 for A and B. And so is there any other member in A and B which is common?
No, sir.
Right. So we in this region we have A and B only. That's where we would now put the 3. All right. So with that being done, what else should I put in? Can you give me an idea where to put the rest?
A only.
All right. So for A only, what we're going to have over here?
1 and 4.
1 and 4.
1 and 4. What else? What else you know?
Sir, you should put 6 in the intersection between B and C.
All right, so the intersection of B and C only, that's what you're saying here?
Yes, sir.
Yes, sir.
All right, so we have common to both B and C 6, and so those go into B and C only. So we'd have 6 here. All right, anything else?
C only put 7.
So we'll put 7 in C only. Is there any member for B only?
No, sir.
No, sir.
All right, so that's what the diagram would look like. Any question? Is everybody clear on what we're doing and why we're labeling the various regions with those elements? Let me see your hand if you are clear. Or should I say, let me see your hand if you are not clear on how we are labeling the diagram. All right, so I'll take it that everybody is pretty much okay with the labeling of the diagram. So we're going to move on. All right, so now suppose you're asked now to determine the members of A intersect bracket B intersect C. So that's for question A, or part A of the question, then part B. Now suppose you're asked to find those members for those intersections. Now, just take the time out to give me, list those members, do them to yourself now, and then now you give me what you get for the answer. So I'll give you about 2 minutes to figure it out. And then now you tell me what the set of members are for both sets. All right, so you want to be able to tell me what members belong into this set. All right, anybody finish with part A? Or probably what I should ask you to do is to walk me through the steps of working out part A. Who would like to do that? And the volunteer? Ms. Waysam, would you like to try?
Sir.
Mr. Giovanni, go ahead.
Yes, for A only is 1 and 4.
All right, now remember, now we already done the diagram. And what we really want now is that represent this part A, where you have A intersect bracket, B intersect C, close bracket. So we want you to tell me what are the members for this set. So how you go about doing that, Mr. Giovanni?
Oh, all right. So the members for A,
which do you take to do you see any similarity with these do you see any similarity with these with any of the laws that you would have learned from arithmetic? Remember, we're looking at operation laws, or laws of operation. Anybody remember those laws?
Yes.
Like the bracket.
All right. Now I'm going to repeat myself. Guys, before you come to the class, you need to spend a little time to review some things. All right, look over some things that you'd have learned, go to the side, look at the topics that you would have already learned, because even though we have learned these things, they are not yet permanent. They are not permanent in your memory yet. And in order to get them permanent, you have to go there from time to time and revisit them, review them, refresh them in your memory. And so you should get into the habit of trying to do some refreshing before you come to the class. Because when you do that, you can have a more meaningful input to the class, because you, by refreshing your brain, you would pick up on something that I may ask you about. So even though those things gone from way back in the beginning of September, there are things that you still need to refresh. All right, so remember we talk about the associative, the commutative, and the distributive law. Right. Do any of these look like any of those laws? And which one?
B intersect C.
Which of the laws
Okay.
does it remind you of?
Oh, bed mass.
Not bed mass. I just mentioned the 3 laws. I told you the laws are, we have commutative law, the associative law, and the distributive law, right? So these are resembling one of them. Which of them these are resembling? Anybody remember what anybody remember what the commutative law states? Guys? Anybody? Commutative law?
Sir, the order in
Um,
which numbers are added or multiplied does not affect the answer.
Right. Now looking at these 3 letters, do we have any changes in the orders? Is the order changing here? When we say changing of order, do we interchange A and B or C and B? Do we interchange them? Do we flip around any?
No, sir.
No. So it means that this would not be the commutative law. So which other law that you know? Talk about the associative law. The associative law states what?
The way in which numbers are added or multiplied in groups doesn't affect the product, sir.
Right. So it doesn't affect the sum or the product. So does this look like the associative law? Mr. Paisley? Anybody else?
I think so, sir.
You think so? All right. What give you a reason to think that way, Ms. Clark?
Sir, because it says the order in which numbers are grouped, sir, it doesn't affect the sum
That's-
or product.
That's not what the law says, you know. What the law says, Mr. Paisley, remind them of what the law says, the associative.
It states that the way in which numbers are added or multiplied in groups does not affect the product.
Right. So it didn't say anything about order. Order means that you're changing how the numbers are arranged. So we don't have any changing in the order. The order is still following A, B, C. So the associative law says, though, the way in which you add or multiply in groups of 2 don't affect the results. So are we adding or multiplying here? Are we adding or multiplying?
Multiplying.
No, we are doing none of the above. But what we are doing, we are associating based on the intersection. right? So we are associating sets in groups of 2. How do you know that we have them in groups of 2?
Because one set is bracketed.
The brackets is what you use to associate. So once you see brackets there, you're associating. So in this case, you associate the B and the C in the top part, or in part A, and the next part, B, you're associating A and B. So whatever you're associating, you put those in brackets. All right. So guys, please refresh your memory, going back to the notes and reviewing them. I know some persons are of the opinion that when you're doing maths, you should be just practicing. But you can't practice without understanding of the theory. And in order to understand the theory, you have to refresh your mind or your memory of what the theories are before you can apply them. So you memorize the concepts and theories, definitions, and so on. Not because I'm going to ask you to recall them on a test, but for your own sake of understanding a question, or in terms of interpreting a question, you need to understand or know these concepts and definitions. All right, so this is actually an associative law, but it is not applying to addition and multiplication, but instead it is applying to intersection. All right, so if we are following the rules of association, we want to see whether or not this obeys the associative law. So if this is so, it means that this shouldn't affect the end result. But if we are working any kind of question, somebody would have said bed mass. In the same context of bed mass, you want to work out what is in the brackets first, right? So if you're working the brackets first, so let us focus on part A, then we want to look at B intersects C first. And to look at that, what we do, look at the listing of B and the listing of C and see if you have any common elements in them. Are there any in B and C? Anything common?
Yes, sir.
So we have 2 and 5. 5. Only 2 and 5?
6.
And 6, sir.
We have 6. So it means that the intersection of B and C, so B intersects C, is equal to these elements 2, 5, and 6. And so that's for this region. I remember it's curly brackets that we must use here. So this means this part is the set of 2, 5, and 6. Now, to see if A intersect with B intersects C, then you have to look in the set A and the set B intersects C. So you look in the set A. Do you have any element common in A with the set B intersects C?
Sir, 2 and 5.
Right. So in B intersects C, you have 2, and you have 2 in A as well. And 5, we have both of them as well. So in terms of A intersect B intersects C, what would be the answer? So the answer would be, what are the common members?
2 and 5.
2 and 5. Everybody agrees? And so to do,
Yes.
to do B, you would have done the same thing, or you done it in a similar way. All right. So if you're doing B, then what you're to look for first is the intersection of A and B. So A intersect B would be equal to what? You look for the set A and B and see what is common in them.
2,
2, 3, 5.
3, and 5.
So A and B, we have 2 common. And then we have 3. Then we have 5. So those are the members of A intersect B. So we have 2, 3, and 5. All right, now, so this set, we are intersecting with C. So now we want to look in the set C to see if there's any member common in C with A intersect B. Is there any member common in C with this set?
2 and 5.
So we have 2 and 5. And so this would be equal to 2 and 5. Now, the question I'm asking you guys, what do you notice about the answer for both section A and section B? What do you notice about the answer?
They both have common elements. So
The part A of the question and part B, what do you notice about the answers? Guys, what is obvious there? It is obvious. What is obvious? The set would be the same. Isn't that so?
Yes, sir.
So if you consider the associative law, what did the associative law state? It doesn't matter how you associate them in groups of 2, you will still get the same answer. So this is obeying the associative property. So it means that intersection obeys the associative law. Is that clear to you guys?
yes, sir.
Now,
Yes, sir.
suppose there wasn't any brackets. Then we would have what? A intersect B intersect C. So what would we be looking for if we were looking for that? We would be looking for the common element in all 3 sets. What would be common in all 3 sets?
2.
2,
5.
2, and 5. So what you notice here, if you didn't have any brackets, you remove the brackets, you're still going to get the same answer. So it doesn't matter if you bracket them or you don't bracket them, or whether or not you associate one group of 2 and a different group of 2. The answers will be the same. So it obeys the associative law. So intersection obeys the associative law. So that's what this exercise is really demonstrating. All right. Now, here we have how we work the problem. So in the problem, in problems of this kind, always work out the brackets first. So we have B and C, we look for the intersection or the common elements. So we have 2, 5, and 6. Now we're going to look at what is common in B and C with A, and we get 2 and 5. And so that's for part A. And similar for part B, we look for the A intercept B. So what is common to that? We have 2, 3, and 5. Then we see what is in the intersection of A and B with C, and we realize it is just 2 and 5. All right, now here we have a similar question. So, so based on what we would have seen, we see that whether you're associating them in bracket in groups of 2, you're still going to get the same answer, even if you don't associate them. All right, looking at union of all 3 sets now. Now, so union means that you're uniting all the members of all the 3 sets together as one. So in other words, when you talk about union, think of a party and you're inviting everybody. So if A, B, and C are, let's say, call them classes, are classes at school, and then now at the end of the year, you're having a party, then you would unite everybody to the one party. So you call out all the members of A, all the members of B, and all the members of C, and you group them together as one big class. So we call that a union, A, union B, union C. All right. Now, what I would like you to do for this example 2 is I want somebody to walk me through the Venn diagram. Any volunteer? Or do I need to call on someone? Is there anyone who wishes to volunteer for this? All right, so let me start out by drawing the rectangle. And I'm just going to randomly call on someone to walk me through. All right, Miss Maywa, Miss McIntosh, can you walk me through labeling this Venn diagram or constructing the Venn diagram?
Yes, sir.
All right, so what should I do in terms of the circles?
Sir, you are going to draw 3 circles overlapping each other.
And how do you come to the conclusion? Draw them overlapping each other.
Because each group have similar numbers in each set.
Okay, all right. I'm taking your advice. So now, based on what you have just said to me, you're going to help me to fill in the different regions based on the elements or the members that we have. So let me label the sets. So using different colors. So this is set A, set B, and the sets. All right, go ahead now, Miss. Let's label the various regions.
Okay, sir. So in set A, you have 3 and 4. 3 is also in set C. So you are going to put
So you said 3,
yes, sir.
A, and C. So what are we doing here?
Okay, so you're going to put 3 Right. Set A and C, right here.
Right here. What do we call that though? What we call
Search
that region?
you.
This region is called what? A and C only. All right, so we're gonna put C here. So that region where you're dealing with only members of A and C is called A and C only. All right, so what else we're going to do now?
Sir, you're going to put the other number in where it's supposed to go. So the other number is 4. 4 is in set A and also in set B.
All right, so where are we putting that now?
So that is going to go right here
Describe the region for me, miss.
in set B and C only.
Right, because I just give you an example. So you
Yes, sir.
have to put 4, B and C only. All right, what next?
In set B now, you're going to put B in set. You're going to put 2 in set B only because you don't have any other 2 in.
All right. So 2 is here, that's what you're saying.
Yes, sir. And 6. 6 is in set B and set C only.
So 2 is here, and you're
Yes, sir.
now 6 is in B and C only.
Yes, sir.
All right. So how did we get 4 here?
Oh, sir, 4 was supposed to be in set A and B only. That was a mistake.
Okay, so it's here. 4 is supposed to be here. All right, so 4 would have been there. So where we have that, we have what?
6.
6.
Yes, sir. In set B and C only.
And what else?
And number 8 is supposed to be in set B and C only.
So